All right, lesson 11.5, we are going to continue our work with percentages. Now we're going to discuss the idea of percent increase and decrease. We're pretty good at raw changes. You know, if something begins at one place and goes up to another place, then we just do the basic subtraction. That gives us the raw change. But in this case, we want to know what is that in terms of percentages. So for example, at the beginning of Chapter 6, Sally took her pretest and scored a 7. At the conclusion of the chapter, Sally scored a 14 on the post-test. What was her percent of increase from pretest to post-test? So again, as I was stating, we're pretty good at looking at this. Sally started at 7 at the pretest, did the chapter, scored a 14 on the post-test. And obviously, she went up by 7 points. But what is this as a percentage? Okay, so we're going to pause this little idea for a second. We'll come back to this. We're going to go ahead and talk about percent change. So percent change, when we say change, amount of increase or decrease, is the amount stated as a percent that a number increases or decreases. And we calculate percent change with a little formula. Okay, and this is one you're going to want to have written down and be able to come back to it to use as you go along. Percent change is calculated by taking the amount of change and divide that by the original or the starting amount. Okay, and I'm going to show you how to deal with these as we go through here. So let's go back to Sally here. So again, she took her pretest of 7, she took her post-test of 14, and our job is to calculate as a percentage what is the amount of change. Okay, so now in my little formula here, the amount of change we've already talked about is 7. Okay, we divide that by the starting or the original amount. In this case, the original amount, the starting amount, is also 7. Well, 7 divided by 7 is 1, and that would be 1.00. Now, as a percentage, remember, we bump the decimal 2 places to the right because we're multiplying by 100. That would be a 100% increase. Now, you might want to say, well, how is it a 100% increase? Well, in this particular case, 7 is where we started, so that would be our full value. It went up by 7, so it increased by its own amount. Okay, which what is 100% of 7? Well, 7. So in this particular case, it changed by, and ignore this little thing here, that's my smartboard not connecting correctly. And anyway, so since it went up by its own full value, it went up by 100%. So she had a 100% increase. So we're going to go ahead and calculate a few more percent increases and decreases. So in this particular case, whatever we're working at here, it started at 36, it went to 45. So I'm going to go ahead, and in this case, I know it started at 36, and over here, I'm going to go ahead and fill this in right now. It started at 16. Okay, and you'll notice from 36 to 45, we're going to end up with an increase. From 16 down to 12, we're going to end up with a decrease. All right, so now our numerators are the amount of change. So obviously, in order to figure out amount of change, we have to do some basic subtraction. Okay, so 45 minus 36 is 9. So that would be my amount of change here. From 16 down to 12 is a change of 4. So at this point, it's just a matter of doing some basic division. 9 divided by 36 is 0.25. And again, if we bump our decimal 2 places to the right, multiply by 100, we have a 25%, and in this case, because it went up, increase. I'm going to just use an arrow. Okay. Now, in the other case over here, 4 divided by 16 is also 0.25, and bump our decimal 2 places to the right, multiply by 100, because we're going percentages out of 100. But in this particular case, you'll notice this is a 25% decrease. so in this particular case, A, our value increased by 25%. And over here, our value decreased by 25%. And again, it's 25% of the original value. Is even though this one up by 9, that is 25% of 36. Where over here it went down by 4. 4 is 25% of 16. Okay, but in either case, based on percentage, they changed by the same amount. One just happened to go up, the other happened to go down. All right, a science application. The heart rate of a grizzly bear slows from 52 to 8 beats per minute during hibernation. What is the percent decrease to the nearest tenth of a percentage? And again, our percent change formula is the amount of change divided by the original or the starting value. Well, in this particular case, the starting value is 52. All right, so my amount of change is 52 minus 8. That is 44. So it changes by 44 beats per minute. Okay, so now 44 divided by 52 is 0.84615. I'm going to go that far for now. And we are bumping the decimal 2 places to the right. And we are rounding to the nearest tenth. So tenths will be right there. So we're going 84.6 in this particular case, because the 1 will not round it up, and then we'll cut everything else off. So, and in this case, we know it is a decrease because it tells us what is the percent decrease. But if you wanted to indicate that arrow downwards, that might be worth having. So, all right, Anthony bought an LCD monitor originally priced at $750, was discounted by $35. What is the reduced price? And I like throwing these things in. It happens to do with we're not actually in this case finding the percent decrease. We're actually being told what the percent decrease is. But I do like to throw these in because these are things that you go into the into a store and you we have to calculate things. We do things with money. 2 good ways to do this, all right, which there's the 1-step problem and there's the 2-step problem. The 2-step problem goes like this. If we take our $750 and we multiply by our percent of reduction. Now I'm going to save the steps here. I'm going to punch it into the calculator, and 750 times 0.35 is $262.50. So that is the amount that's coming off. So I then have to take, let me go ahead and change colors here, okay, and take 750 and subtract $262.50. And in this case, actually, it's probably just as quick to go ahead and put it in the not in the calculator. Go ahead and just do it as it is to punch it into a calculator. And there's 7. I'll borrow again. 8 and 4. So it looks like we're going to be paying $487.50. Now that's the 2-step problem. Here's the 1-step problem. Okay, and if we think about this as percentages, okay, $750 is the 100% price. But in this particular case, we are subtracting 35%. Well, if I take 100 and I subtract 35%, I am left with 65%. So I'm actually going to be paying 65% of the price. Now watch what happens here. If I go 750 and I multiply by 0.65, and again in this case just for the sake of speed, I'm going to punch that into my calculator, and that ends up being $487.50. And you'll notice here, voila, those are the same. So one of the shortcuts that we have is if we realize that, again, instead of doing this in a two-step problem, if I realize that, you know what, if I take off 35%, I'm going to be paying 65%. Well, if I just multiply by that 65%, I get to the answer right away. Okay? Or if we're doing like sales tax in the state of Michigan, and we know that we pay 100% of the price plus 6%. So technically I am paying, 106%. Well, if I take my price, whatever it is, and I multiply by 1.06, 106%, I get to what I'm actually going to pay in one step instead of two. So for those of you who want to do this as a one-step problem, try to think about what am I going to pay as a percentage and multiply by that value. So, all right, practice time. Need help? Come see me. I'm here for your aid. Good luck.